I found out what the synchrodyne concept is. In the initial transmitter, these frequency source was left continuously on, and this thing was pulsed synchronously, so either a lot of amplifier stages, or it would be enough gain to supply 1,400 watts of pulse power from probably maybe 1 watt here of pulse power. And it would be high isolation off, high gain on. And that's all they did in the basic SAGE radar transmitter. Except this group of nuts, what they did, they came along, they pulsed the mixers, and they pulsed each one of these stages individually. And I have recollections of going through pulse modulations and such, and they might pulse this one on, pulse this one on. It was a real crazy, odd setup for the way they pulsed these different stages on and off. What they're actually doing was loading a thought form here, shifting it to here, shifting it to here, loading more, shifting it, loading, maybe shifting it backwards, loading more. And they built up the esoteric function as the esoteric function bounced around in all these stages in the whole transmitter. Now, another aspect of this is what we have here. We have a noise source. This is a white noise source synchronized by Mr. Nikola Tesla's whirligig zero-time reference, which I'm not going to go into here. And they use this noise to essentially pulse noise modulate the stay low, pulse noise modulate the outputs of the synthesizer, which means you ended up here with a carrier with white noise modulation on it. If you go through your signal processing, you'll find out that white noise is 50% correlated to anything and everything within its bandwidth. That's right out of college, people. That's in your college textbooks. Look it up, it's in there. Which means this signal now is coherent to itself, and it's also coherent to hyperspatial functions, because white noise essentially comes out of hyperspatial functions. If anyone wants to debate that, I'll debate that with you later. And of course, they had the zero-time reference, which synchronized the white noise function. So at this point, they started to build the thought form within the pulsed signal. Of course, there's still no output here. They then split it and sent it to the other transmitter. The other transmitter was just this group here. You know, the pulse modulators and the 3 IPAs and the P8. At that point, it went into this IPA number 1, boosted to 7 kilowatts, went to IPA number 2, boosted to 75 kilowatts, went to IPA 3, boosted to a megawatt, went to the final amplifier, which is a first cousin to a magnetron known as an amplitron, which is essentially a backward, slow-moving wave structure oscillator, which anyone's interested in, I can explain that to you what it does later. And goes through its different isolations, goes through the band-limiting filter, so this thing doesn't spread to hell and gone and back and wipe out every TV on Long Island and wipe out every radio on Long Island. You know, this thing spread as far and wide. And then they produced 12 megawatts here. They lost a megawatt in the isolator. It means you had to water cool this. They lost another megawatt in this filter. That was water cooled. And if you look in the Montauk station, you'll still see all the water cooling equipment in the antenna room for these. And it went out to the antenna. Of course, these stages are individually pulse modulated also. So we had 14 pulse modulation points in this transmitter. Of course, the human lattice structure is based on 7s, 14s, and 21s. It's the magic number 7 again. And they built the thought form by pulsing all these stages, and they did some weird ways of pulsing. This is essentially how the transmitter actually worked. As I said, I'm not going to go into very deep technical detail here. Anyone interested in it can see me later, and we can go much deeper into technicalities of this. I'm trying to give you people an overview of what this did. You can get the tape and the paper, and this will all be in it, and you can study the block diagram and such. What we have here, pictures again. That's the stay low. I apologize, it's a terrible picture. The camera went kaflooey. This is the best of the 2 pictures I was able to take. This is 5 channels of crystal oscillators, multipliers, summer, other amplifiers. This chassis multiplies it, and this is their noise source chassis. You can see this noise source essentially is a noise tube fed into a very wideband, high-gain IF strip, and at this point you got tons of noise. The bandwidth on this is maybe about 10 megahertz. And all this stuff here was the synchronization from the 30 hertz sine wave they put into that port there, and they took the noise out of a port here. This, of course, is the synthesizer that drove this, which is the FM oscillator, and this is the first mixer in this system. Use a power stage at 101 megahertz, and this thing provided all the frequencies for this oscillator and all that other good nonsense. This also was modulated by the white noise source, and this chassis also, one of these stages, is pulsed by the white noise source. It's right there. There's one of these ports over here that goes through amplifiers here that pulses these. But these tubes, if you look closely, not in this picture, you'll see these tubes are added later. And they just pulse one of these amplifiers. Remember, this frequency generator chain was essentially in the old stage transmitter on continuously. They used the synchrodyne to get the on-off effect. Because when you start up a crystal oscillator, it starts, smooths up the frequency and stays there. They wanted to be able to pull out a pulse which was exactly on frequency at all times, and switch from one pulse, one frequency to another frequency, and always be on frequency. So all these oscillators here and these crystal oscillators here had to be up and running continuously. And they had trouble with phasing and such as the different mixers came up, so the whole RF generator chain was on constantly. Although this mixer in the Montauk project was pulsed. They didn't care about the phase, apparently. This is your final mixer. This, of course, has a 3CX100A5 tube in it, which some may recognize as a 2C39 from World War II. That's that nice little White House trial that puts out 100 watts. Then we go back to our block diagram. We now will look at the synchrodyne. This is 8 stages, each one 3CX100A5s or 2C39s. And voila, there they are. 1, 2, 3, 4, 5, 6, 7, 8. People, they had these nice, expensive ceramic iMac triodes in here. You can see where they blew air through them. Each one of these has an air input and an air output. And this thing sat there, and this built up at least 50% of the thought form in these boxes. These are cavities. You know, TEM mode cavities. These darn things. Now, these were 7214 Ceramo-Wax pentos, which are about that big around and about yay tall, had rings on the bottom for the electrodes. These sat in cavities about yay long and about yay square, and had huge fans blowing them. They had 2 of these. This thing, this tube is 6952, looks like a robot. That tube is about yay big around, has a round section like a flying saucer, about yay thick. It has things sitting down that you connect to it. It has 2 legs sitting down for the water cooling, 2 legs going up for the water cooling. It has the plate on top, and the thing actually looked like a robot. That was this stage here. That thing put out either 50 kilowatts CW or a megawatt of pulse power. That's a lot of power, people. This, of course, was waveguide at this point. You'll put this into a coax cable. You've got so much voltage in the coax cable, you get any of alveolar standing waves. Of course, they're not alveolar standing waves. Folks, that's right out of your college textbooks. That's out of your tech school textbooks. If you had a standing wave problem, you could sit and watch your coax cable explode. I think we've all seen coax cables explode from SWR. That drove this big thing, which we'll have pictures of later. All these stages were removed from the Montauk site.